Okay, welcome to Similar Triangles Part 2. I just recorded a 40-minute video and realized that my microphone was turned off, so I erased it all. I'm going to do it all over again, so I apologize if I'm moving a little quickly. I've already done it once today. So if you do have any questions as we're going along, of course, just email your teacher, drop in their extra help or their office hours, ranging anywhere from 1 to 3 p.m. So today's learning goal, use similar triangles to solve for missing side lengths and angles. And remember from last lesson, we proved that two triangles are similar by a method, angle, angle. Of course, if you do know two angles, you know the third angle, so you really could call this angle, angle, angle. Two by SAS method. So that's saying that if an angle is contained by two sides, so if that angle is in the middle of two side lengths, we call that side angle side. So if you need two side lengths and an angle, we can prove two triangles are similar. And thirdly, if we know three side lengths, so side, 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 we can prove that two triangles are similar if they are in the side lengths are in the same ratio or the same scale factor of each other. I'm going to use those two words, ratio and scale factor, quite a bit today. You're going to get used to those. So question number one, if we know two triangles are similar, we can use the ratios to find the side lengths. Determine if each pair of triangles is similar. If they are, find the missing side length. So this question actually wants us to find that they are similar. So first we have to think about how we're going to prove these two triangles are similar, whether we want to use angle, 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 side, or side, side, side. So taking a look at between the two triangles in number one, I see we have a common angle here, 35 and 35. Then we have two missing angles. We have two different angles on the far side, so we can do some easy math. 180 minus 75 minus 35. This angle must be equal to 70 degrees. Thus, we have two angles that are the same, so these two triangles must be similar due to angle, angle. Of course, we could take a look at this one and say 180 minus 35 degrees minus 70 degrees is equal to 75 degrees. And we notice that all three angles are the same. So any triangle that has three of the same angles must be at bare minimum similar. Then if they have the same side lengths, they would be congruent, but it's pretty clear here we don't have the same side lengths. So we're going to use the ratio of the side lengths to find that missing F, that missing side length. There we can see that angle is going to be the same as that angle here. So we want to take a look at, let's take a look at the base first. We have a ratio between these two triangles. So this side length 5 isn't identical, it's not congruent to the base here, to this 8, but it's similar. So what they're saying there is whatever you did to 5 to get it up to 8, you multiplied it by something, or that ratio, you're going to multiply every single side length by that amount. So this F, while this distance of this orange line right here isn't the same as 10 centimeters, it's been multiplied by a scale factor to get that, or the ratio of the side lengths are the same. So kind of two different ways of thinking about it. You can think about it as that scale factor, or you can think about it as a ratio of the sides. Sometimes ratios scare students off, so I start by using that scale factor and then switch into ratios pretty quickly because it is the clearer way. I'll do both methods right now just so you can see them. They are the exact same thing, just a different way of writing them. So first way, taking a look at the ratio of side lengths. So the bases, so I know that side DF, I could even write that first, side DF to side AC. Those two sides are similar, D and F and A and C. And whatever that ratio is, it needs to be the same ratio as side DE to AC. B. So I'm saying that side DF, well, we know the value of that. We can say the ratio of 5 to AC to A needs to be the same ratio as DE. I don't know what DE is. They just called it small f. But I need to know that side is 10. So those ratios need to be the same. So it's an unknown here. We're trying to solve for f in this equation. So I'm going to multiply both sides by 10. If I multiply this by 10, multiply this by 10, those two are going to divide to 1, and I'm going to be left with just f on this side, and on this side I'm going to be left with 5 times 10 divided by 8. By the way, this is the exact same as saying 5/8 times 10. Doesn't matter which order you do it there, because technically that 10 is over 1. Multiply your numerators, multiply your denominators, and you get the answer of 50 divided by 8 is f. I'm going to reduce this fraction a little. 25/4 is equal to f. If you want to leave it as a fraction, that would be fine. I see this goes in, 6 full times and 1/4 of another time, so 6.25 if we want to write that out as a decimal, or of course you could have typed that into your calculator at the very beginning. So we're saying side length is 6.25. And what I was talking about before, about that scale factor, if we already know the answer, go back and take a look at how that scale factor works. Well, I'm saying from the smaller triangle to the bigger triangle, there's a number in which we multiply every side by to get the answer in that bigger triangle. So side length DF times our scale factor. Get this one in a different color. DF times our scale factor. I don't want to write SF for short because that might get confusing. Needs to equal the bigger counterpart, needs to equal AC. So DF is 5 times some scale factor. Don't want to write that out again, so I'm just going to write a blank. Needs to equal the value of AC, needs to equal 8 centimeters. So 5 times blank is equal to 8. So blank is obviously 8 div 5. If you want to leave that as a fraction, you can. Or if you want to throw that into your calculator, and we should get the answer of 1.3 is 6. So 1.6 is equal to our scale factor. So that means that every side in our smaller triangle gets multiplied by 1.6 to get the larger side in our bigger triangle. So then we would say, okay, well, f times your scale factor. Scale factor needs to equal your bigger side, 10 centimeters. So f, we don't know what f is, that's what we're trying to solve, times, we do know our scale factor is 1.6, needs to equal 10 centimeters. So f times 1.6 is equal to 10. So if we divide both sides by 1.6 and say that 10 div 1.6 will equal to f, 10 div 1.6 is a bad decimal, is equal to f, and we get the answer of, throw that in your calculator, 6.25. What do we know? We get the same answer for either one. So scale factor kind of has some common sense to it. While the ratio method, we are doing the exact same thing in both methods. The ratio method, as we move on, is what your teacher is going to use more often than not. Okay, if you have any questions, please shoot an email to your teacher or drop by office hours from 1 to 3 each day. Taking a look at question B. So if we take a look at question B, we first want to show that they are similar. So if we take a look at the angles, this one's pretty obvious here. We've got a 60 and a 60, 92 and a 92. And while we don't know that third angle yet, simply doing 180 minus 92 minus 60 would get us that third angle. Technically, it's just angle. You only need 2 angles to prove that a triangle is similar, because obviously that third angle is going to be equal. So while we are working with similar triangles, we can write that right off the bat. Triangle ABC must be similar to triangle, do it in the same order, so FED. Notice the order in which I wrote that out, and that's by angle, angle. Technically, I could write angle, 3-angle theorem or 2-angle theorem. So we're working with similar triangles, so we can take a look at the ratio of the side lengths now, as long as we're working the same, the similar side lengths. So between 92 and 60, or between E or F and E, right here, this side length D needs to be scaled up to get the same side length as our larger triangle, as 18. And same thing on the other side. If we take a look at the smaller triangle is 15, so between F and D, we've got the side length of 15. So we need to scale that number up to get the answer of 24. So the question is, what is that scale factor? What is that ratio that makes these two triangle side lengths similar to each other? So I'm going to do the ratio method to start. And you can see how I set this up. If you want to pause the video and do it yourself and then double check your answers, go for it. So our ratio, I'm going to say of F to D. So side length FD needs to be the same ratio of A to C. That ratio needs to be the same as F to E, as A to B. So FD is 15 over AC is 24ths. F to E is unknown, just going to leave that as D, to AB, which is 18 centimeters. Then a little bit of calculator work. We can multiply both sides by 18, and we can say 15 times 18 divided by 24 is equal to D. So that'd be 270. 270 divided by 24 is a little over 11.25. Use your calculator for that one. And we get the side length of D being 11.25. So we've scaled up 11.25 by the same amount that we scaled up 15 to get 24. So if you want to take a look at the scale factor way, if this way kind of makes common sense to you right now, it's the exact same way. You don't have to use this method by any means, but they're saying 15 times something, our scale factor, equals 24. So if I want to find out what my something is, I'm going to do 24 divided by 15 is going to be equal to 1.6 is equal to my scale factor. Coincidence, I got the same scale factor there. So my scale factor is 1.6. So to get from the smaller triangle to the bigger triangle, I'm going to have to multiply all side lengths by 1.6. So I know that D has been multiplied. D times my scale factor needs to be equal to my larger side. What's my larger side? 18. So D times 1.6 needs to equal 18, or D is equal to 18 div 1.6. I'm going to double check that on my calculator. 18 divided by 1.6 is equal to 11.25. So we get the same answer. It is essentially the exact same thing, just kind of different ways of writing it. We're probably going to stick to the ratio method more often than not. Okay, so once again, questions on that, drop by office hours, email your teacher. I think it's pretty straightforward there. Try a bunch of those out in your homework. You'll get good at them very shortly. So now we're going to take a look at a new set of triangles. Notice there's 3 sets of triangles here. Before we do anything, I want you to put 3 arrows on these 3 parallel lines, showing that lines PR, MN, and BC are all parallel. If these lines were not parallel, we could not do this question. So first thing we're saying right here, lines have to be parallel. If AB is equal to 10, I'm going to label my sides. A to B is equal to 10. M to N is equal to 12. And B to M is equal to 4. So just that little guy right there is equal to 4. We can take a look and solve for this missing side B to C. So this missing base down below is what we're going to be looking for. So we can take a look at and see why these triangles are similar. I'll show you real quick, and then I'll erase all the extra writing I'm going to write here. But if we take a look at angle, angle, angle. So if I take a look at triangle A, excuse me, AMN and triangle ABC. Well, the first angle is easy to prove because they are sharing the same angle. Both triangle AMN and triangle ABC share angle A. Then if we take a look at this angle right here, coming from point M, judging by our F pattern, if we remember from previous lesson. So if I take a look, it's upside down, kind of backwards looking F, but that is indeed the F pattern, that the interior angles in an F pattern need to be equal. So those two angles need to be equal. Just going to erase that for now, it doesn't get too busy. And then thirdly, if I take a look at this angle here at point N, I can do the exact same thing, the F pattern. It's almost backwards here, but there's my upside down and backwards F. Interior angles in a F pattern are equal to each other. So therefore I proved that triangle AMN is similar to triangle ABC by angle, angle, angle. And you can see we could do the exact same thing for triangle ARP as well. We'd have to use the Z pattern in there, but it wouldn't be too tricky. So let's try and find this length of BC here. How do we find that length? Well, this is like saying we have two triangles. They're lying over top of each other, but if it helps to draw them separately, I'll do this for our first problem. I probably won't continue doing this all the way along. AMN, this is 12. That's all we know there. And our bigger triangle that we're trying to prove is similar, pretty bad drawing there, is ABC. And those two triangles are similar to each other. We're trying to find what is that missing side right there. So if we take a look at, I guess we know 10 and 4. So this side length is 10 here. 10 minus 4 is 6. That side length is 6 there. So we're trying to show what did we do to this small triangle, triangle AMN, or a scale factor. What did we multiply it to get to our big triangle ABC? So I'm going to use the ratio method that we were talking about before and say, well, MN, so the base, or MN is my base, is 12. So MN needs to be multiplied by something to get up to question mark, to get up to BC. That ratio needs to be equal to the ratio of my side lengths. So AM to AB. We're saying what did you do to 6 to get all the way up to 10? That makes sense. So we can fill out some values that we know. MN is 12. BC is unknown. I'm going to leave it as BC. AM is 6 and AB is 10. So I don't like my unknowns on my denominator, so I'm going to flip both my fractions, make it nice and easy for me. That's a trick you'll probably use quite a bit this unit. Once your unknown is on the numerator, significantly easier to solve. Multiply both sides by 12. So I'm going to have BC is equal to 10 times 12 div 6. 10 times 12, 120. 120 divided by 6. Looks like we've got 20 times that will go in. So our length of BC needs to be equal to 20. Hope that was clear. I showed quite a bit of work there. I didn't have to draw out those extra triangles. I was just trying to get you to see where those similar triangles are. Maybe we'll try number 2 without drawing those similar triangles to the side and just solving them right in the picture. So let's see what we know and what we're looking to solve in number 2. AC is 12, so this full side length is 12. AB is 8, this full side length is 8. And AN is 9, little guy here is 9, and MN is 7.5. Just a reader beware, these diagrams are not to scale. So once again, we need to have parallel arrows showing that those are parallel. If those aren't parallel, this question is impossible to solve. So you could picture my 2 little triangles drawn off to the side, but what I'm going to try to work with are the small triangle, highlighted here in orange, triangle AM to N. I'm going to show that that triangle, or I already know that that triangle is similar to this larger triangle A to B to C. So those 2 triangles are similar due to angle-angle-angle theorem, or angle-angle theorem. I want to drop that third A. So then I take a look at my side lengths, and I can say that, okay, let's take a look at AN. I know AN, so that side length there from A to N is in the ratio to the bigger triangle. AC is the same side in the bigger triangle, so I multiplied AN by something to get the number 12, to get AC. And that ratio, whatever that number is there, needs to be the same ratio for all sides. So my base would come next, MN, the small base, multiplied 7.5, multiplied by my scale factor, needs to get my base of my larger triangle. And then, of course, my third side follows suit. So AM times something needs to equal to AB. These 3 different equations in here, or 2 different equal signs, we can work with 2 parts at a time. So let's take a look at these 2 here. Fill out my knowns and unknowns. AN is 9, AC is 12, MN is 7.5, and BC is unknown. So we leave BC as unknown. Once again, here's that trick. I don't like my unknown on the denominator, so I'm going to flip all my fractions upside down. So I have 12/9 is equal to BC divided by 7.5. Multiply both sides by 7.5, so you get 12 times 7.5 divided by 9. Divided by 9. Pull out your calculator for this one. BC, and we get, what is that, 90. 90 divided by 9. Nice even number, whole number of 10. So we have one of our unknowns, BC, being 10. So next one I'm going to take a look at is AM. So AM, you can see in our ratio, is our top right. So I'm going to take a look at my next ratio and say that, okay, I can, of these 3, I can say that AN over AC is in the same ratio of AM to AB, right? We don't have to use all 3. We only need 2 of them. We only need 1 equal sign. I chose to use AN over AC just because it was given. I didn't have to do any calculations there. Of course, you could replace AN over AC with MN over BC and just use BC of 10 of what we just found. But I'm going to choose to use what was given just because I'm 100% certain that was correct. So AM, we don't know AM. The full thing from A to B is 8, but A to M is unknown. Leave that as AM. I do know the full thing is 8 there. Once again, my ratio, my unknown is on my numerator, so I'm going to do 9 times 8 div 12. is equal to AM. We got 72 divided by 12. 72 divided by 12 is 6. Once again, I'm showing quite a bit of work here just so you know where I'm getting these numbers from. If you start to skip some steps along the way, it's probably a little understandable, but show as much work as you feel necessary there. AM is equal to 6. What else were they asking us for? And our last one is MB. MB, oh, it's just that little segment right there. So we know AM is equal to 6. So if we want to find out MB, MB is a small little segment right here. Didn't even notice that. Well, if we know this is 6 now, what we just found, we know the full thing is 8. MB must be equal to 8 minus 6 is equal to 2. Nice and easy. Questions on there? Fire away, email to your teacher, or drop by their office hours. Okay, question number 3. We're going to get a little more challenging here. We're going to start to use that top triangle, triangle ARP. So if we take a look at what they gave us, or I guess we could show that they're similar right off the get-go. So we know that angle A and A, those are similar to each other because they are opposite angles. Then if we take a look at our Z pattern, so if I go a Z pattern here, we know that the interior angles in a Z pattern are equal to each other. So that means that this angle right here and this angle right here must be equal to each other. Then if I take a look at my Z pattern in the opposite order, so backwards here, I'm saying that the interior angles in a Z pattern are equal to each other, so those two angles are equal to each other. And what do you notice by angle theorem, or angle theorem? That triangle AMN is similar to triangle ARP. Notice the order in which I wrote it out there, very specific. That is ARP, not APR. So we can label our given sides knowing that we have two sets of similar triangles. Of course, I could do the same thing with triangle ABC. So triangle ABC is similar to triangle AMN, we proved before, which is also similar to triangle ARP. So first one here, I'm going to label MN is 12. PR is 8. So those are my bases, need to be in the same ratio. AR is 4. AP is 6. And we need to find AM and AN. So I'm going to highlight those. AM is what we're looking for, and AN is what we're looking for. Not too challenging, we just have to use our ratio method once again. And notice that that top triangle is almost mirrored, so AN is similar to AP, and side length AM is similar to AR. So we can say that PR, let's start with our bases, those are nice and easy, there's no mirroring those. PR is similar to NM. NM. So that ratio needs to be in the same ratio that AP is to AN, and that AR is to AM. Once again, we have 3 sets of equations there, or 2 equal sign. We can just work with bits and pieces at a time. So let's take a look at the first 2. PR is our base, is 8. NM, or MN, doesn't matter there, is 12. So that is the ratio we're working with. Like 8 multiplied by what is equal to 12. So everything needs to be in that same ratio. So let's take a look at AP and AN. So AP was 6. We don't know AN, that's our unknown. So I'm going to solve for this unknown now. AN, once again, don't like my unknown in the denominator, so I'm going to move that to the numerator by simply flipping all fractions in that equation. Multiply both sides by 6, so you get 12 times 6 div 8 is equal to AN, and we get 72 divided by 8, and we get 9 is equal to AN. Now we can take a look at my second fraction I'm going to work with. I'll write it again just so we're absolutely clear. But my PR over NM, I'm going to now use my AR over AM. So that's my ratio of my bases, which is 8 over 12. Needs to be the same as the ratio of my other two side lengths. My other two side lengths, AR, scroll it to see that, is 4 over AM is our unknown. So I guess we could have set this up, flipped it before, so we don't have to flip it now. But once again, we don't like our unknown in the denominator. I'm going to flip both those fractions upside down, multiply both sides by 4. 12 times 4 div 8 is equal to AM. So 12 times 4, 48. 48 div 8. We have got AM equaling to 6. And I think that's the only two things the question was asking for, AM and AN. Relatively straightforward, but using the top triangle that has been mirrored. So once again, I want to stress the fact, highlighted here again, that, that these two side lengths here, AR, has been scaled up to get AM. So it's almost like it's been mirrored there. And that AP, this 6, has been scaled up to get AN. So it's almost like a reflection there. If you're unsure what I'm going on about there, you can try out some homework problems. They have it, or you can ask your teacher. And last but not least, going to use all 3 triangles now. So we're going to say that we've already proven these triangles are similar. So I know that triangle ARP is similar to triangle triangle AMN, which is similar to triangle ABC. So those 3 triangles are similar, and that's if and only if these are parallel. So draw in your parallel lines there. And we have fill in what you know, what you don't know. MN is equal to 8. BC is equal to 12. So that's the ratio of our bases there. Check these off as I go along. AM is equal to 6, just a little guy there. NC is equal to 1.5, and AP is equal to 4. AP is equal to 4. So we can tackle this one side length at a time. What we're really looking for is a complete ratio, something that we know 100% to find that scale factor, to find a complete ratio. So if I look at our 2 bases here, so this is going to be the giveaway, I know that this ratio, whatever I did to 8 to get up to 12, I need to do the same thing to the other 2 sides of the triangles. So I'm going to start with that ratio there of MN because it's complete. I know both the numerator and the denominator. So that ratio of the side MN and BC, then we can pick 2 other side lengths that need to be in that same ratio. I'm going to pick AM to AB. So that's saying that the ratio of those 2 orange lines needs to be in the same ratio of these 2 green lines. AM, which is 6, I know part of it, to the bigger, what do you multiply 6 by to get that bigger green line from A to B? And the reason we picked MN and BC is because when you start filling in some values, MN is 8, BC is 12. So we have part of that ratio done already. AM is 6. AB, don't know what AB is, going to leave AB as AB. And what do we get here? Don't like my unknown on the denominator, so I'm going to flip both my fractions. I feel like I've had to say that 10 times today's lesson. You're going to use that trick over and over again. Multiply both sides by 6, so we get 72 divided by 8 is equal to AB. I feel like we've done 72 divided by 8 before as well, so we get 9 is equal to AB. And we get one more piece of the puzzle. So I've found AB there. Next up, let's take a look at AN. I'll do this one in a different color. So AN is the other side of that triangle. But how are we going to solve that one? So we've got our bases. So let's say MN over BC. That ratio needs to be the same as AN to AC. So if we take a look at what we know, we don't know. We've got 8 over 12. That's a ratio. It needs to be in the same ratio to AN, which we don't know what it is. AN, which we don't know what it is. And we don't technically know AC as well. So I'm going to leave that as AN plus 1.5. Because you can see from A to C, this whole distance right here is just simply AN plus our little 1.5 there. So because I have the same variable here, it shouldn't be too hard to solve. I'm going to get rid of my denominators, or cross multiply, as you guys like to call it. 8 times AN plus 1.5, so multiply both sides by that, is going to be equal to AN times 12. So I multiplied this side by 12. I'll do it in green just so you saw what it's doing. 12 times 12, those divide to 1, so I have to multiply this side by 12, or AN times 12, and then I multiplied, do it in orange so you can see, this side by AN plus 1.5, so these would divide to 1, those divide to 1, but now I'm going to have to multiply this side by AN. Whoa, don't know what happened there. Let me try to get out of this. Oh no, what is that? Let me get out and go back in. It's still there. Ah, there we go. I've never done that before. Let me finish this one off. Is AN time, or plus 1.5. And we get this equation here. So distribute your 8 in. You're going to get 8 times AN plus 1.5 times 8. Half of 8 is 4, so 8 plus 4 is 12, is equal to 12 AN. And bring this over to the other side, so we're going to get a 12 is equal to 12 AN minus 8 ANs is 4 ANs. Divide both sides by 4, 4, 8, 12, and we're going to get a 3 is equal to AN. Hopefully you got the same thing as me. I didn't lose you with that little text box that came up there. So we've solved for our second side, AN. Next we're looking for AR. So AR, if I go back to my diagram here, is that small side right here. So they're looking for the distance of A to R. So we're using that top triangle now. And remember that it's been mirrored. So AR to AM is of the same ratio as another side. So we can use that value we just found there to solve for our next one. I'm going to do it underneath just so I can see a little more. And say that A to N is A to P, so that ratio there, AN to AP, because we now know what AN is. So that's the ratio we're going to know, equal to the same ratio of AR, which we don't know, to AM, which we were given. So AN, as we just found, was 3, divided by AP, which we were given, was 4. I'll write that 3 in there just to remind myself. AR is what we're looking for. So our unknown's on our numerator. That's always nice. Divided by 6. Multiply both sides by 6 to isolate for AR. 6, 12, 18. 18 divided by 4 doesn't go in quite perfectly, but 4.5 is equal to AR. And that is the third side we were looking for. So we use the similar triangle of ARP, that top small triangle. And the last one we're looking for is that distance, let me switch over here, is that base of that top triangle. So that base of that top triangle, we can say is in ratio of the base to either AMN base, triangle AMN base, or triangle ABC base. It doesn't really matter which one you use, but I'm going to say use triangle AMN, the smaller one. So MN, the base of the right side up triangle, the ratio to RP, the base of the upside down triangle, the small one up top, is the same as any one of the side lengths. I'm going to use AM to AR. So don't forget that that is mirrored when you're looking at the side lengths there. MN is 8, RP is unknown, AM is 6, and AR is what we just found, was 4.5. Unknown is in the base, so I'm going to flip this fraction upside down, a little easier to solve. Then I'm going to multiply both sides by 8. 4.5 times 8 divided by 6. Throw that in your calculator if you're unsure. It looks like 36 divided by 6. 36 divided by 6 is 6. So we get RP, side length RP, or PR, same thing, is equal to 6. Hopefully that was clear for you guys. If you have any questions, drop by office hours or email your teacher. Stay tuned to Power Learning page. Complete your daily exercises on Khan Academy.